Hi friends, my name is Laura Marie Coleman and I'm glad you're joining me for this grade 4 video. In today's video we're going to talk through the Illustrative Math Grade 4 Unit 4 assessment, but before we start I just want to show you a couple of resources that you can find on the PEMA website, PEMAEDU.com, and then you're going to scroll down and click on resources. And then if you scroll down here to where you see the grade levels, when you click on grade 4, there will be a few resources that you can download. So if you scroll down past the number lines, you can get to the place value charts where you can download something like this. And you'll also be able to find a decimal comparison resource. So this would be really helpful, both of these, if you print them out and put them in a clear sheet protector. Students can use dry erase markers on them, and these templates are going to help them with tenths and hundredths and comparing decimals, and the place value charts will help them with the whole number comparison and rounding. So let's dig in to the unit assessment. On number 1, you'll see this is a great opportunity for students to use that place value chart. They're going to be finding all the representations for the number 89,500. You can see the first one is word form. Then we have word form for 8,950. So if we don't set it up in the right place value units, this could be a bit of a distractor. And if we get thrown off by B, we're probably going to be thrown off by C, where we have the expanded form for 8,950. Then D is 80,000, which is true, but then the digits or the numerals 9 and 5 are in the wrong place value units in this expanded form. And then this last one is the expanded form for the correct number. Number 2, again, a place value chart would be really helpful if they can learn to write the numbers one on top of each other so that they can see them right next to each other and compare each place value unit one at a time, starting in the largest place value. I've color-coded here for you to see how far students might need to go in order to compare and decide if these numbers, which one is greater and which one is less. So you'll see here that if we start in the 100,000s, both of these have 500,000s. When we go to the 10,000s, the first number has 8 10,000s and the second number has 9 10,000s. So no matter what comes next, this has more 10,000s, so this number is greater. In B, if we start in the 100,000s, despite the fact that the first digit in this number is a 1, and the first digit in this number is a 9, we know that 100,000s are greater than 10,000s. I'm going to know that 127,937 is greater. This last one, we have to go pretty deep. So when you start in the 100,000s, both have 3. When you go to the 10,000s, both have 8. When you go to the thousands, both numbers have 6. When you go to the hundreds, this one has 900s and the other one has 800s. So again, regardless of what comes after this, because there are more hundreds in this number than this number, that means this number is greater. So 386,981 is greater than 386,898. Let's take a look at this next one. So we know the distance between New York City and Boston is 225 miles, and New York City and Salt Lake City is 10 times as far apart. Students can explain or show their reasoning a few different ways. They need to understand that 10 times as far means I need to multiply 225 times 10. And in finding that, I could think about unit forms. I also can think about moving it on a place value chart. So the reason why a lot of students say, well, times 10 means add a 0. The reason why we add the 0 is because when we multiply a number times 10, we're shifting that number over to the next place value unit larger. So when 225 is multiplied by 10 and all of these digits shift over one place value to the left, we now have 2,000s, 200s, 5 10s, and 0 1s. So we're filling in the 0 because the number moved to the left when we multiply by 10. Number 4 is where those decimal comparison visuals might come into play. Here we need to identify what expressions have the same value as 30 hundredths. So if students were able to identify that 3 rows or 3 columns of this model is 30 hundredths, they would also see that it is the same as 3 tenths. If students are able to think about this more abstractly, they'll know that I can multiply the top and bottom by the same thing to create an equivalent fraction. I also can divide the top and bottom by the same thing. So if I divide by 10 to get to 3 and divide by 10 to get from 100 to 10, I can see that 30 hundredths is equal to 3 tenths. For B, D, and F, if your students can put these numbers and draw them on a place value chart, it's going to be a little bit easier for them to compare and see that, just like I said before, if we start in the largest place value unit, this is not equal to 30 hundredths because it is only 3 hundredths. And if this 3 tenths and 30 hundredths are the same, and then the last one I have 3 tenths, so these are equal, but then because I also have 3 hundredths, that means that this is actually greater than 30 hundredths. If we cycle back and look at C and E, the two where we're doing addition, when we look here, if 7 tenths in this one was actually 7 hundredths, it would be true. But what students need to look at is make sure that the units are the same. We can't add tenths and hundredths. And when we make 2 tenths into 20 hundredths and we find the equivalent of 7 tenths as 70 hundredths, it is not 30 hundredths, it's actually equal to 93 hundredths. And then this last one is actually equal to 30 hundredths because we need to convert 2 tenths to hundredths, which means we have 20 plus 10 hundredths, and that gives us 30 hundredths. So really thinking about language, place value, and equivalent fractions is going to be huge for this. Number 5 is about addition and subtraction algorithm. We want students to have a wide range of strategies, but they do have to know the algorithm because sometimes that is the best way to solve the problem. Both of these questions, some things to notice is they do involve regrouping and renaming. There is not regrouping or renaming in every place value. It's just a couple in each one. And it's really nice that we are not subtracting with regrouping across zeros. So if this is something that many students find very challenging and something that your students are struggling with, know that while it's an important struggle to work through with them, this last piece is comparing decimals. So again, just like I said before, use that place value chart, write the numbers one right above the other on the place value chart so you can compare place value unit by place value unit. Start in the largest place value unit and only go as far as you have to until you find one that's different and can determine which is greater or if they are equal. If one number has more digits than the other, I know it's greater when I'm dealing with whole numbers. When I'm dealing with decimals though, when I add an extra 0 on the end, it doesn't change the value at all. So 4 and 20 hundredths is exactly the same as 4 and 2 tenths. So that's a big conceptual understanding students need to gain in this unit. Here, we want to make sure students are going place value by place value and looking at what number is greater. Even though the 9 is greater than the 1 that comes after it, because 3 tenths is more than 2 tenths, that is what makes this greater. In C, again, we have the same digits, 1, 2, and 7, in the same order, but place value is key. Because we have tens and ones and tenths instead of ones, tenths, and hundredths, that means that 12 and 7 tenths is greater than 1 and 27 hundredths. And again, drawing pictures for these and representing them visually, drawing those 12 holes as opposed to one hole, is going to really help students solidify this understanding. And then additional place values don't necessarily mean it's a bigger number. If we're doing whole numbers, this is 75 compared to 8. But really, it's 7 tenths and 5 hundredths, which is less than 8 tenths. So starting at the largest place value and comparing which number has more of those units is going to be the key to comparing decimals. Last page, we have rounding. So select all true statements. So we're using the number 287,164, but note that students need to be able to think about rounding to all of the different place values. They need to be able to round to the nearest 10, 100, 1,000, 10,000, and 100,000. Really building some capacity for students, whether it's using a place value chart and thinking about what units it's closer to, using a number line, whether it's vertical or horizontal. Students need to be able to round to all of those place value units. And be on the lookout. PIMA will be putting out a video on a suggestion that we have for strategy on rounding that might be helpful. And then number 8, we are comparing these two school districts, Los Angeles and New York City. We're comparing those numbers, so same strategies as before, noting that New York City has a greater number of students. How many more? They're going to subtract to find the difference. The tricky part is C. So thinking about how do we know how many more students New York City would need to get from 984,462 students to 1 million. The subtraction for this is really hard. I have another video that I did on a couple strategies that we can introduce students to for problems like this in ways that they can use what they know about properties of operations to solve this subtraction using some different strategies. So here, just a quick hit. This one is using constant difference and knowing that if I subtract 1 from both, the difference doesn't change. So I can subtract 1 from 1 million and make it 999,999, and that is way easier subtraction than trying to regroup across all these zeros. Another strategy is counting on, and again, the student thinking could be to leverage if I take 1 away and count on in each place value to get to 999,999, and then count on 1 more because this is 1 less than the actual goal of what I want to get to. Then another one they might use is compensation. So instead of taking 1 away from both, I'll just take 1 away from 999 or from 1 million to get 999,999. Then I can do my subtraction and then I can add that 1 back at the end. So just some thoughts on how you might do this. Take a look and see what lessons emphasize the concepts that you think your students are going to struggle the most in. If you have any questions, feel free to reach out. Thanks.